solving quadratics and other inequalities in one variable. Suppose you were given that x squared minus 3x minus 10 was greater than or equal to 0. Now, since it's a positive x squared, that means it opens upwards. Now, if the graph goes like this, it would be enough just to find these two roots, or zeros. Call them a and b for a moment. Well then, all of these, so this is where it's positive, and here it's positive. In the middle here, it's negative. The y values are negative. Remember, this mess is equal to y. I want to know when y is greater than or equal, when y is greater than 0. So the answer would be if x is bigger than b, or over here, all these values, x values, have one thing in common. They're less than a. Now that's one of the scenarios. The other scenario can be, see, in the scenario we just looked at, the vertex was below 0. What if the vertex is positive? Well, then the answer would be, it's all y values. And the other scenario would be if it were just 0 right at the vertex. If I called the vertex a, then the answer would be, it's positive except when x is a. Because when x is a, the y value is 0. And 0 is not bigger than 0. 0? Is 0 bigger than 0? No. No. Okay. So, I guess what I'm hinting is, you need to know the zeros. You need to know what the zeros are. Now, just be real crystal clear. If you find two zeros, then your graph cannot have been of that type. If you find the zeros, well then at least cross the zeros. If there's only one zero, well then make sure you cross that one zero. Live up to what you're getting. So let's find when it equals 0. Try to factor maybe. X squared minus 3x take away 10. Since it's understood to be positive 1x squared, we'll play x followed by a number game times x followed by a number game. And the two numbers should multiply out to negative 10 and add up to the number in front of x. And two numbers that multiply out to negative 10 but add up to negative 3 are negative 5 and positive 2. And I want to know when it equals 0. Well, if this times that equals this number, then this or that must be 0. Can't multiply two things and get 0 if none of the things itself were 0. Well, this is 0 when x is 5 times this. Well, this is 0 when x is negative 2. And since it's a positive x squared, I know how to graph this. It crosses at 5, it crosses at negative 2. I may not know how low to go, but basically it looks like this. I mean, I admit it could have looked like this. Could have gone down a lot lower. Or it could have gone down very little. Can go down very little. But nonetheless, it's positive here in any of those cases. It's positive when x is bigger than 5, and it's also positive when x is less than negative 2. Okay, you don't have to graph it. Once you get the two numbers, the solution is x is smaller than the smaller of the two numbers, or x is bigger than the larger of the two zeros. And possibly your teacher would want you to use the union symbol, which means or. Now, let's just change this problem ever so slightly. If on the very top line, that is the original problem, it said equality, if it had the equal sign as well as greater than, well then everywhere you should have equal signs as well. Either everything you write has an equal sign or nothing you write has an equal sign. My goodness, how do you tell? Oh, simple. Look at the original problem. So the original problem says equal. Well then, any symbol you put should have the equality symbol. If it didn't say equal, like the original problem had, well then, nowhere should you write the equal line. Nowhere should you put the equal line. Either they all have it or none of them have it. Okay, there's nothing hard there. Students just mess up that completely, but there's no reason to. Look at the original problem. If it has an equal line, well then any inequality symbol you write, please put the equal sign. If the original problem does not, then your solution should not. Nowhere should you have a greater than equal or a less than equal. If the original problem did not include equal, then you don't anywhere. How about this? 5x squared plus 19x is less than or equal to the number 4. Well, I bring the 4 over. You want to know when this quadratic, bring the 4 over, is negative 4, when this, which is equal to y, is less than or equal to 0. Since it's a positive x squared, we know it goes this way. If it does have some zeros, if it has 2 zeros, well then it's going to be in between where it is less than or equal to 0. If this is a and b, then x can be in between a and b. And since the original problem had the equality, then anything and everything I write has the equality. So I just want to find out these zeros. Now, we can try to factor it. 5x squared plus 19x minus 4. Well, we get 5. Yeah, only 5 and 1 multiply out to 5. 5x and 1x, which I'll just write as x. Now, to get negative 4, you can have 1 and negative 4, 2 and negative 2, 4 and negative 1, 4 and negative 1. You can have negative 1 and 4. You can have negative 2 and 2. And you can have negative 4 and 1. There's a number of combinations to try. I mean, 19. I see 4 and 1. If I put plus 4 here, I see a 20. If I put a negative 1 here, 20 minus 1 is 19. That's the factoring. If you can't do that, fair enough. Go and use the quadratic formula to find out that x is 1/5 or x is negative 4. If this minus that is 0, so if this times that equals 0, then either this is 0 or that's 0. When is this bracket 0? Well, if you subtract two things and you get 0, those two things must be equal to one another. Divide by 5, divide by 5. X is equal to 1/5. If x plus 4 is 0, well then x is equal to negative 4. So I found my A and my B. Okay? Negative 4 is a smaller number. 1/5 is a larger number. X is in between. X is in between negative 4 and 1/5. There is your answer. If you are asked to write it in interval notation, it's between negative 4 and 1/5. And since you're allowed to have equality at the end points, put closed brackets. And here are two different ways of expressing the same answer. inequality and interval notation. Okay, let's try this one. Now those were quadratic. The title was Quadratic and Other Inequalities, or Solving Quadratic and Other Inequalities. That is solving quadratic inequalities, which you just did. Now we're going to solve others. Not everything is quadratic. Suppose that you were told that x minus 2 times x plus 1 times x minus 6 was greater than or equal to 0. Question is, when can it change signs? When can it change signs? Let's let this be x plus 1. When can it change signs? And since this is a continuous function, if you multiply this here as a continuous function, because if you multiplied it out, it's just a cubic equation, and cubics either go like that, or they go like that, but you can draw it without lifting your pen. Well, it's going to be 0 when, before it can change signs, so let's concentrate on this one. Before it can change signs, before this can change signs, it has to be 0, because it's continuous. That means it just can't go from -3 to +2. It has to hit every number in between. So if here it's -2 and up here is +3, it had to be 0 in between. Right before it was 0, it was negative. Right after it was 0, it was positive. This is the only time it can change signs. Right before this 0, it's positive. Right after the 0, that is when x is bigger than that number, that x value right there, it's negative. Does it always have to change signs at is 0? Well, actually no. If the graph goes like this, well, to the left, here it's 0 right there. To the left it's negative, and to the right of that 0, it's negative. But if it's going to change signs, it's going to happen at 0. That's one thing I guarantee you. It will change signs only, it can only change signs around the 0. It can change signs far away from a 0. That is, if a graph crosses the x-axis, a continuous graph, if it crosses the x-axis here, and here, and here, it couldn't possibly change signs right there. Because when it crosses, like now it's positive. It can't change signs right there, because then it would have to be positive, positive, 0, and then negative. But it's not. I said it only crosses the x-axis here, here, and here. It couldn't be 0 right there. It couldn't change signs around that x value. Because that would mean it would have to be 0 here, and maybe negative before and positive after. Okay. So if you understood all that, excellent. But it's not really going to help you to solve this. What you need to find out is the zeros. If this times that is 0, well then one of those factors are 0. When is this 0? What take away 2 is 0? What take away 2 is 0? Well, 2. So x is equal to 2. Because that's the name of the unknown. Some number plus 1 is 0. What's the number? Negative 1. Some number, when you take away 6, gives you 0. Well, that number is 6. 6 minus 6 is 0. Now you should write this in increasing order. Smallest number, next smallest number, largest number. Okay, this is important. So now, using these three values, we make intervals. And here's a number line. I want to make intervals that do not include those three numbers. That is, I go from negative infinity all the way up to negative 1. Do not include negative 1. Never ever include infinity. Then I want to go from negative 1 to 2. Negative 1 to 2. Don't include those endpoints. Then from 2 to 6. And then from 6 to infinity. And what I want to do in each and every one of these four intervals is I want to know what the signs are of each of my factors, which means I need to erase some of this. I need to know the plus minus signs of my factors. X take away 2, x plus 1, and x minus 6. Now you can go into each of these and pick numbers in between, go into each of these intervals and pick test numbers. No. Why waste the time? When is x minus 2 greater than 0? What type of numbers, when you take away 2, leave you with something left over? How much money do you have in the bank so you can take out $2 and still be in the positive? The answer is more than 2. And you can add 2 to both sides if you have to, but you're going to get x must be bigger than 2. Now, which of these four intervals, 1, 2, 3, 4, have the x values? Remember, these are the x values between negative infinity, negative 1. X is in between negative 1 and 2, etc. Which of these four intervals have x's bigger than 2? And the answer is the third and the fourth one. The first two, x minus 2, will be negative. I mean, you can take a number. What's in between negative 1 and 2? I would pick 0. Well, 0 minus 2 is negative. Okay, so we did x minus 2. Let us do x plus 1. When is it bigger than 0? If we know when it's bigger than 0, then we can figure out when it's less than 0. The other cases will be less than 0. Okay, we take away 1 from both sides, and we conclude x has to be bigger than negative 1. The first interval is not bigger than negative 1, so it's not going to be positive. But the other three intervals, all these numbers in here are bigger than negative 1. Okay? Between negative 1 and 2, if you're not including negative 1, and you're not including 2, only in between, these numbers are bigger than negative 1. I know they are, because these numbers are all to the right of negative 1. That means they're bigger. Okay, the last interval is x minus 6. When is it bigger than 0? Well, when x is more than 6. If you have more than 6, well then, when you take away 6, you'll have something left over. And only the last interval has numbers above 6. All the other ones are negative. See how quickly I got these three? I didn't have to keep testing test numbers. In my opinion, teachers don't expect students to think. So now, I want to know when the product of these three things are bigger than 0. Well, a negative times a negative times a negative is a negative. Odd number of negatives. A negative times a positive times a negative is a positive. A positive times a positive times a negative is a negative. Multiply 3 positives, you get a positive. Now I'm ready to answer the question, but first I'm going to look to see what the question is. We want to know, when is it bigger than 0? Just look straight up. between -1 and 2, and between 6 and infinity. So -1 and 2 do not include the endpoints because it does not say equal. Or 6 to infinity. Never ever include equality at infinity. Do you include equality at 6? No. Why? Because the original problem didn't say equal. And there it is. If you wanted it in interval notation, this is a between interval. X is in between -1 and 2. Or, these numbers are all bigger than 6. Or X is bigger than 6. So these are two ways of writing the same answer. Find out where the product at the beginning equals 0. That is, find out where, or find out when, or where, that's okay, where each factor is 0. It's gonna change signs. If it's gonna change signs, then change signs right after 0. So let's try one more. What if you have negative x plus 4, x minus 3 times 2x minus 8. Okay, and we want to know when this is less than or equal to 0. Okay. When is this factor 0? Well, it's not when x is 4, because 4 plus 4 is 8. So it must be -4. When is this factor 0? It's when x is 3. When is this factor equal to 0? Well, it's when 2x is 8. Because if 2x were 8, if this number here said 8 instead, 8 minus 8 is 0. So the name of the unknown, 2x, must be 8. So what is x equal? Well, 2 times 4 is 8. So x is equal to 4. And we put the three numbers in increasing order, and coincidentally, it is. So we make up our intervals from -infinity up to -4, and then from -4 to 3, and then from 3 to 4, and then from 4 to infinity. If that part was hard for you, don't worry. Draw a number line, put -4, 3, and 4. And you can't be these numbers. Well, you can be less than -4, which is that interval. You can be in between -4 and 3, which is that interval. You can be in between 3 and 4. You can be more than 4, which is that interval. If that makes it easier, fine. Just get it correct. And then you look at the factors. But this one's a little bit of a pain in the neck. You have this negative in front. We can think of that as -1. I didn't mention it, but that is a factor, and it's never 0. So don't worry about it in terms of this list. It's never 0. When is this factor 0? When x is -4. I mean, I could have given you negative x plus 4 and another factor x squared plus 6. This is never 0, because if you square a number, you'll get 0 or above. And then if you add 6, it'll be more than 0. You won't be negative. So not every factor gives us 0. And if you just have a little negative sign in front, it will not give us 0. It's a -1, which is never 0. But nonetheless, I can't stress it enough, you have to put it. Or you can multiply both sides by -1. Now, this factor right here, I would factor out the 2. if you want, we can say 2 is the factor. And the other factor is x minus 4. The fact that 2 is positive won't, if you didn't put it, it won't matter. But if you're negative, because multiplying by a positive won't change the sign anyway. But you can't lose a negative. And regardless of what x is, -1 is always -1. If x is in this interval, this value is negative. If x is in this interval, if x is 0, -1 equals -1. If x is in here, like 3.4, 3.7, -1 is negative. If x is more than 4, like 73, -1 is still negative. In fact, it's -1. Okay, what about x plus 4? Well, when is x plus 4 positive? Just bring the 4 over as -4. When x is bigger than -4. Now, -4 is going to be one of these cutoff numbers. -4 is here and here. This interval on, those x values are more than -4. That's why it's positive and this one's negative. X take away 3. When is it positive? Just add 3 to both sides, or bring the -3 over to the other side as +3. When x is more than 3, x minus 3 is positive. Well, these two intervals, the x's are more than 3. Here, the x goes up to 3, not more than 3. So these two are positive, and the left two intervals, x minus 3 will be negative. Now 2, that's an easy one. No matter what x is, 2 is 2. In particular, positive 2. So it's positive. X minus 4, when is it bigger than 0? Bring that over as positive 4. If x is more than 4, x minus 4 is positive. Only the rightmost interval has x's more than 4. The others do not. Okay, so we're multiplying. We have 1, 2, 3, 4 negative. That's an even number. That makes it positive. If you multiply a string of signed numbers, just count how many negatives you have. If you have an even number of negatives, be positive. You have 1, 2, 3 negatives, that's odd, so it's negative. Multiplying by a positive won't change. If you're negative and you multiply by a positive, you still get a negative. If you're positive and you multiply by a positive, you still get back what you started with. Multiplying by a positive doesn't do anything. And if you multiply by negatives an even number of times, you get an even number of negatives, you can always pair them up. And this will be plus, and this will be positive, and this will be positive. You multiply a lot of positives, you get positive. Now if you're an odd, you can pair them up, but then you're going to have one left over. And a positive times a positive times a positive is positive, times a negative, that's negative. Okay, so we're just going to count the number of negatives. There's 2 of them, that's positive. 1 negative, that's odd, so it's negative. And now I'm going to look to see what the problem asks for. But first I'm going to erase stuff so I have some place to put down my conclusion. I'm going to try to erase something. Okay. So I want to know when that product will be less than or equal to 0. Less than 0 means negative. Here and here. This interval and this interval. So -4 to 3 or 4 to infinity. But since it says equal, I'm going to include my endpoints. I'm going to include -4. I'm going to include 3. I'm going to include 4. I will never, ever, ever include infinity or negative infinity. Why? Because it's not a number. What would it mean to include infinity? you can go up to infinity. If you're below infinity, you're a real number. If you're infinity, what are you? That's not a number. It's like 1, 2, 3, 4 infinity. You can never reach infinity. So everything's the same. Let me state what I'm really getting at. As long as it's 0 here, this sign doesn't come into play until the very, very, very end. I just looked at it to see which signs were negative, because it was less than 0. If this would have been positive, I would have said those are positive, and then I would have picked those two intervals. Okay, find out where it equals 0. Now, if the right-hand side was not greater than or less than 0, so less than 4, I would bring the 4 to the other side. It has to be greater than or less than 0. Now, if you have a fraction, there's only one difference in the fraction. Suppose you want to know when this is greater than or equal to 0. Basically, you have two factors. You have the top factor and the bottom one. The top factor is 0 when x is negative 3. The bottom one is 0 when x is 1. So, we make up our intervals from negative infinity. And if the number line helps you, here's negative 3, here's 1. You can't be either of those two numbers. An interval cannot contain those numbers. So you can have one interval here, a one in between, and one out here. That is, the first one, this one here, is from negative infinity up to negative 3. The next one is between negative 3 and 1. The next one is more than 1. That is from 1 up to infinity. And I want to know the plus minus signs of the two factors in each of these intervals. The factors being x plus 3 and x minus 1. Oh, x plus 3. When is it bigger than 0? Take away 3, take away 3. X is bigger than negative 3. These two intervals have x's bigger than negative 3. This one does not include negative 3, but includes everything to the right of it, well, up to 1. And then this one picks up at 1. So those are the two that are positive, and this one's negative. X minus 1. When is x take away 1 bigger than 0? Well, if x is more than 1. If you have more than 1, if you have more than $1, you can spend something and have something left over. Being bigger than 0 means you have something left over. How much money do you have so that if you take away, that if you spend $1, you'll have something left over? I have more than $1, more than 1. Only this interval right here has x's more than 1. The others do not. Now division is just like multiplication. Negative over negative is the same as negative times a negative. It's a positive. You have an odd number of negative signs, it's negative. Here we had two negatives, that's even as positive. Here, if you want to, you can say 0 negative, which is an even number, it's positive. Or you can say positive divided by positive is positive. Now, here's where, so far, is exactly the same as solving x plus 3 times x minus 1 is bigger than 0. It's very similar to solving this one. But what's the big difference is, in the one I just wrote, you can let x be 1. You can include 1. Because if you included 1, 1 plus 3 is 4, 1 times 1 minus 1 is 0, 4 times 0 is 0, and yes, that is greater than or equal to 0. The problem is, if you divide, you have x plus 3 divided by x minus 1. If you let x be 1, 1 plus 3 is 4. 1 minus 1 is 0. Is this bigger than 0? The answer is no. Because this doesn't make sense. You can never divide by 0. So even though it said equality, I can't allow x to be 1. That's the big difference between the product and the quotient. Whether it says equal or not, the bottom cannot be equal. The bottom cannot be equal to 0, I should say. The bottom, even if it says equal to 0, the bottom can't equal 0. Because a fraction only equals 0 when the top is 0. 0 divided by 5 is 0. But 5 divided by 0 is not 0. You can't divide by 0. Now, if it didn't say 0 at the very beginning, the problem just said greater than 0, then there will be no words. It will be exactly the same. Okay, so nonetheless, we want to know when we're bigger than 0, and it's those two cases. Negative infinity up to negative 3, union 1 up to infinity. Never include the infinities. Question is, what brackets do we put here? Since it says equal, I'll put closed brackets for the x values and make the top factor 0. There's only one top factor, here it is, and it's 0 and negative 3. I will include that. Since the bottom is 0 at 1, I will not include 1. Okay, now if you really didn't catch that, if you make the mistake on an exam, you're just going to lose a point or two. You're not going to lose 9 out of 10 points. And if you do, your teacher's really messing up. I once had a teacher who would take off 9 out of 10 points if he made a very, very silly mistake. And he just didn't understand why that was unfair. And he wondered why I stopped coming to class. Okay. Try one more of these. The different variable, k. You have k plus 4 over k minus 7. You want to know when it's less than or equal to 0. So since it says equal, I will not entertain k equaling 7. So basically I want to know when the factors are 0. When are the factors 0? Well, that's when k is negative 4. Negative 4 plus 4 gives you 0. And the bottom factor, when is it equal to 0? Well, you need to be on top of this. The two things I circled, we're subtracting them. And we're getting 0. It is the difference between them or 0. One is not any bigger than the other. Oh, you mean they're equal? Absolutely. So, we want to draw the intervals. We want to bypass negative 4. We want to bypass 7. In fact, if you prefer, and it's not a big deal, you can use this chart right here. Maybe I'll put the negative 4 and the 7 above the line. Okay, so there's my partition. I have stuff to the left of negative 4. I have in between negative 4 and 7, and beyond 7. Okay. I just need to put one more line here to put the factors, which are no longer k's. It's alphabet soup. Don't worry that it's not k. Now, let's look at what we did here. We kind of did the work. If instead of having equal, I had greater than, well then there it is. K has to be greater than negative 4. This is true for all of them. If instead of equal it says greater than, all the ones I've done so far, I could have just done that. So which intervals are bigger than negative 4? Well, here's negative 4 here. Anything to the right will be positive. To the left is negative. If I'm bigger than 7, then k minus 7 is positive. Bigger than 7 is to the right of 7. That is here. That's these intervals. The other ones are negative. Alright, now we're dividing. Negative divided by negative is positive. Positive over negative is negative. Positive over positive is positive. Now I'm going to look at the problem. They want to know when it's less than or equal to 0. That means negative. When's it negative? Okay, it's negative when k is in between -4 and 7. Now, if it didn't say equal right here, if it didn't say equal here, if it didn't have that equality line, that would be my answer, and that would be it. And if I wanted to write it in a different notation, I would put it that way. But it does say equal. It does say less than or equal to 0. Well, you just have to worry about the bottom. K minus 7. K cannot equal 7. K cannot equal 7, but it can equal other endpoints. It just can't equal 7. And there it is. You're done. Okay. Let's try one of these. We'll have to do a little algebra, and then it'll look like the ones we've just done. So you have 2 over x minus 5 is greater than or equal to -1. Gotta get one of the sides to be 0. How about I add 1 to both sides? On the right side, I get 0. But really on the left side, I don't want to add 1 that way. How I want to add 1 would be as x minus 5 over x minus 5. First, that's clearly 1 because top and bottom are the same, and they have the same denominators. So in addition, the denominators are the same. Keep it. And if you have x, and you take away 5, but then you add back 2, you're at x minus 3. If you're at x, you take away 5. 1, 2, 3, 4, 5. X minus 5. And then you add 2. Okay? 1, 2. So I am right here. Here's x. I took away 1, 2, 3. That's x take away 3. So this here means x minus 3 over x minus 5 is greater than or equal to 0. And I add these, which is what I did right here. Here's my answer. X minus 3 over x plus 5. The right-hand side, -1 plus 1 is 0. Okay. So now, it's just like the last problems I've done. In fact, we won't do this one, but rather we'll spend time setting up another one. Setting up means get into the form that I just left this last one in. Similar to the problems we've just have been doing. Suppose you have 3p plus 4, and you're dividing this by p minus 5, and this is greater than or equal to 6. Well, you need to take away 6 from both sides. You need to take away 6 from both sides. The right-hand side is 0. Now, how am I going to write the 6? Well, if I have p minus 5 in the bottom, and I have 6 times p minus 5 on top. This here is 1 times 6 is 6. What I really have is, so I'm subtracting, the bottoms are the same, keep them. The tops are 3p plus 5, plus 4, this piece, minus 6p, take away 30. 6p, take away 30. If you have 3p, and you take away 6p, you took away 3p's. if you have 4, positive 4 is 4. If you have 4 and you take away a negative 30, you have 34. Plus, you can change both of those signs. You get 4 plus 30, 34. So that's what we get. Except I'm just going to write the 30, I'm going to write it as 34 minus 3p. 34 minus 3p divided by p minus 5 is greater than, let's stick with just greater than 0. We haven't done just a greater than. In fact, we'll do this one and it'll be the last one. So I want to know when we can be 0. When is the numerator equal to 0? Again, it's a subtraction. That means the two things we're subtracting, they're equal. Divide by 3. Divide by 3. So 34 over 3 is equal to p. The denominator, p minus 5. When is it equal to 0? When p is 5. This is a little bit more than 10. It's more than 11. So I know in terms of number line, here's 5 and here's 34 over 3. 34 over 3 and 5. Divided by 3. Okay, so I want to know when the numerator is bigger than 0. When it's bigger than 0. This is when 34 over 3 is bigger than p. There's only one reason why 34 over 3 is greater than p, and that's because p is smaller than 34 over 3. When is p minus 5 bigger than 0? When p is bigger than 5. Okay. So here, if you're less than 34 over 3, that is, we have 3 intervals. The left two ones, that's where p is less than 34 over 3, and that's when that factor is positive. Oh, okay. So to the left it was positive, to the right it was negative. This is 34 minus 3p. Now what about p minus 5? Well, p minus 5 is positive when p is bigger than 5. Bigger than 5 is the right two intervals, not the left one. These numbers are less than 5. These numbers are bigger than 5. That's why they get the positives. And we're dividing them. We're dividing them. We get negative, positive, negative. Dividing. 34 minus 3p by p minus 5. And then to the left of 5, I'm negative. In between, I'm positive. Bigger than 34 thirds, I'm negative. Well, I want to know when I'm positive. You want to look here instead? Positive. Well, the answer would be positive. Only one. In between here. P is in between 5 and 34 thirds. And since it never ever had equality, I do not put the equal lines there. That is why I'm going to erase them. Interval notation, 5 up to 34 thirds. Do not include the endpoints. And there's the answer. Okay, you have to get one of the sides of the inequality to be 0. Okay, that finishes this section. Good luck on it.